Good evening. If a giant star collapses, we expect two outcomes, a neutron star or a black hole. Some propose a third, a near black hole collapse that stops before the point of no return and creates a gravastar. The interior would inflate with an outward-pushing energy, and an ultra-rigid shell would hold everything in. The difference seems small, but it changes the story. Instead of vanishing behind a horizon, light and matter can hit this shell and answer with delays. On the outside, gravity misleads. Orbits, jets, and gas disks look like those of a black hole. Inside, the mechanism is different. If this is real, how many black holes in our catalogue would be imposters? That shifts the total mass of galaxies, forecasts of mergers, and the toughest tests of gravity. The uncertainty isn't a technical footnote, it's a change in the ruler we use to measure the universe. Why do some find gravastars more unsettling? Because they swap a definitive limit for an active edge. It can vibrate, store and release energy, produce faint echoes of violent events. The threat isn't an obvious abyss. It's a phenomenon that imitates almost everything and only gives itself away in the final milliseconds. What would a spacecraft see if it orbited just a few kilometers above that shell? Let's take that mental tour. First, the approach. Tides that stretch, heat, and light up the gas, as near a black hole. Then, the edge, where part of the glow can linger and return. Next, the clues in the data. Tiny echoes in gravitational waves after mergers and subtle differences in brightness, very close to the shadow in radio images. Along the way, we explain each idea in plain language. A horizon is the point of no return. Here we talk about an outward pressure that prevents the horizon from forming. The hypothesis appeared around 2001 and has no observational confirmation so far. In the end, what's at stake is our trust in the words we use. When we say black hole, are we describing nature or our best approximation? If gravastars exist, they force us to separate the two. Lie down calmly. We guide the steps, unhurried, until noise turns into understanding and you can sleep, knowing where the doubts are and where solid ground already exists. Have you ever wondered if everything you thought you knew about the death of giant stars, those cosmic behemoths whose final moments light up the universe, might be incomplete? That there is, perhaps, an even stranger fate awaiting them than the dark silence of a black hole or the dense, fiery remnants of a neutron star? Imagine for a moment stepping beyond the familiar crossroads where these cataclysmic objects normally reach their dramatic ends, and being presented with a hidden third pathone so subtle that until recently it was little more than a mathematical curiosity, but now whispers to us from the edges of theory and possibility. When astronomers first mapped out the destinies of massive stars, the choices seemed clear. The core either collapses into a neutron star, a kind of stellar ember made of nuclear paste and neutron soup, or continues its inexorable fall, compressing to the mysterious nothingness of a black hole. You might have pictured black holes as the darkest gulfs possible in the fabric of reality, a place where the gravitational pull is so great that not even light, the ultimate speedster of the cosmos, can escape. For decades, this pairing neutron star or black hole seemed a complete menu, exhaustive in its logic. But in the year 2001, two theoretical physicists, Paul Mazur and Emil Mottler, quietly introduced a profound third way, the gravastar, short for gravitational vacuum condensate star. The very idea is so radical that it gently forces us to revisit what we mean by boundaries, by surfaces, and even by the nature of information itself. What, then, is a gravastar? Start by picturing the universe's most iconic heavyweights, black holes. At the core of a black hole lies a paradox, a private madness. The event horizon, a mathematical surface so closely hugged by gravity that anything crossing its invisible threshold is forever hidden from us, its fate sealed. But Mazur and Motola asked, must the collapse of a massive star always end in this horizon, in this irrevocable swallowing? With mathematical elegance, they proposed an answer that tiptoes around the conundrums that have haunted black hole physics for decades, especially the infamous paradox concerning information and the vanishing of entropy. Here's where you must let your intuition off its leash, just a little. The Gravastar presents itself to the cosmos with all the external gravitas of a classic black hole. It bends light, sculpts orbits, and would at first glance cast an almost indistinguishable shadow in the images sent back by telescopes peering across millions of light years. But just beneath its surface, everything changes profoundly. Instead of plunging into a singularity where the known laws of physics shatter, as with a black hole, a Gravastar replaces this fatal interior with something altogether different, a region filled with a vacuum energy, a kind of cosmic anti-gravity, the de Sitter phase, as physicists call it. Imagine space itself, imbued with a tension so curious that it does not pull inward, but pushes out. The pressure here is negative, meaning it acts in the opposite direction to normal matter. For those who are used to thinking of gravity as the ultimate sunk cost, this is already a conceptual step into the wild. Surrounding this core of repulsive vacuum is not an endless abyss, but a shallow, slim but ultra-rigid barrier of exotic matter, described by what physicists call a stiff equation of state, where the pressure is nearly equal to the energy density. It is almost like the surface tension on a soap bubble, but orders of magnitude stronger. This shell counteracts the core's expansion, holding the contradictory forces in perfect, uneasy balance. The effect? Instead of a true event horizon, you get a physically tangible border, a quasi-surface sitting just a sliver outside what would otherwise have been the black hole's event horizon, the Schwarzschild radius, named in honor of that mathematician who solved the equations for a static sphere of mass so early in Einstein's revolutionary theory of general relativity. This border is not a horizon, it's a boundary. That may sound like splitting hairs, but in physics, there are few distinctions more significant. A horizon, by definition, is unreachable from the outside. If something falls past it, it's gone, cut off from our universe, its atoms and information lost in the absolute darkness. But a boundary, a shell, a surface, these ideas conjure the possibility of return reflection, absorption, even communication. If such a shell truly exists, it could, in principle, intercept or return signals, store or radiate energy, and possibly encode information that would otherwise be lost forever behind the curtain of a black hole. In this sense, the Gravastar offers to resolve, at least in theory, the existential riddle of what happens to information that falls into a black hole. Does it vanish? Or could it re-emerge, preserved in some altered or encoded form? If you were to envision the physical structure of a Gravastar, let these ideas settle in for a moment. There is an interior space-time that resembles the strange, expanding universe of de Sitter cosmology, calm, empty, swelling with positive vacuum energy and negative pressure, like a nugget of the infant universe arrested in time. Encasing this is a thin but infinitely dense crust, where the known laws of physics are stressed almost to their breaking point. Out beyond this lies an unremarkable vacuum, mathematically indistinguishable from the outer envelope of a Schwarzschild black hole. To any observer circling at a respectful distance, a spaceship orbiting at millions of kilometers, a far-off telescope peering through dust and light-year everything looks utterly black hole-like. It is only in the final desperate approach, in the fraction of a radius, that the distinction emerges. Instead of crossing a one-way membrane, one might, in principle, crash upon this shell, perhaps even experience a bizarre echo or reflection, a physical reminder that a boundary, not a horizon, is at work. But why, you might ask? Did scientists even dream up such a thing? The answer lies in a central anxiety that has haunted black hole physics since the dawn of quantum theory. You see, black holes are not just gravitational monsters, they are information sinks. Anything that falls past their event horizon is thought to lose all accessible details except mass, charge, and spin, what physicists call the no-hair theorem. Now, according to quantum mechanics, information cannot simply vanish from the universe. This creates a tension so profound that it has been dubbed the black hole information paradox. How, then, can these two pillars of modern physics, general relativity and quantum theory, be reconciled in the heart of a black hole? This is where the Gravastar offers its most alluring promise. By swapping the event horizon for a tangible shell, it sidesteps the need to lose information irretrievably. The pressure-negative core resists full collapse, the shell resists dissolution, and together they arrest gravitational ruin right at the brink. Instead of entombing the collapse in a singularity and infinitely compressed point, where physics utterly fails, the Gravastar halts, just shy of that outcome. It is, in some sense, a cosmic compromise, a star that resists both explosion and the abyss. From the outside, nearly all features are preserved. Gravitational lensing, orbital motion, the warping of space-time are as they would be for a true black hole. But on the inside, and in the invisible near-surface region, the story diverges wildly, keeping alive the hope that information, and maybe even some echoes from the star's dying heart, could one day resurface. You might be tempted to believe such an idea should reshape our understanding of the cosmos overnight, but the Gravastar, for all its theoretical elegance, remains a creature of possibility, not confirmation. No observation to date has demanded its existence. Our telescopes, from the Event Horizon Telescope mapping the millimeter shadows of supermassive objects, to the gravitational wave detectors listening for the final ringing notes of colliding compact objects, have measured phenomena that fit spectacularly with the expectations for black holes. In some domains, such as the thermal emission from the very center of our galaxy or the nature of echoes in gravitational waves, the evidence remains circumstantial, constraining, yes, but not yet final. Yet the value of the Gravastar hypothesis is undimmed by its current observational invisibility. It serves instead as a conceptual mapmaker, sketching out the outermost territory of what is physically plausible in our universe. Its most provocative lesson is precisely this, that there need not always be a chasm marking the boundary between the known and the forever lost. Sometimes the border is a physical shell, not an event horizon, a transition zone rather than an annihilation of all that came before. As you mull over this tension, let the vocabulary settle in your minder horizon is the irrevocable limit, where time and space curve so completely inward that return is impossible. A quasi-horizon is a surface so close to the ideal that, in practical terms, distinguishing it from the true horizon is a Herculean task. A physical boundary, on the other hand, is active, storing, potentially radiating, a kind of living interface where new physics can emerge. Swapping out a horizon for a boundary shakes the philosophical and physical bedrock. It means the final fate of matter, energy, and information must be rewritten in softer, less fatalistic terms. Still, you might wonder, what seeded this idea's birth? For that, you must recall the interplay of quantum fields and gravity. How, in the crucible of a black hole's formation, energy densities and curvatures soar to such heights that new phenomena can be triggered, just as phase transitions in ordinary matter can turn water to ice or vapor. The Gravastar reaches for that analogy, proposing that the pressure and energy at the threshold of collapse becomes so extreme that the core undergoes a kind of gravitational phase change, settling not into a singularity, but into a vacuum-dominated state, characterized by pressure negative enough to counteract gravity itself. The boundary is where this new phase gives way to outer normal space-time gravitational wall, taut with the tension of the cosmos. The intellectual beauty of Gravastars is that, although the details are mathematically sophisticated, the underlying principle is physical. Rather than allow the collapse to run to completion, nature may, just possibly, prefer a third solution, a compromise, poised on the edge of what is physically allowed. In doing so, the Gravastar does not merely evade the problems of singularity and information loss, it reimagines what it means for something to be lost in the first place. Suppose, too, you are an observer gifted with unlimited sensitivity. What would you actually see when looking for Gravastars amid the crowd of black holes? The short answer is probably nothing obviously different, unless you are looking with the imagination, patience, and ingenuity required to tease out the most delicate clues. Because the exterior gravitational field is designed to be indistinguishable from black holes, as predicted by Einstein's equations, most of the regular signs binary orbital motion, accretion disks swirling at relativistic speeds, even the deep silhouettes cast against luminous backgrounds are essentially duplicated. However, The devil is in the details. The presence of a physical shell, rather than a horizon, might offer up minute, perhaps elusive differences. The possibility of subtle reflections, delayed signals, or thermal emissions in response to infalling matter. Whether these would ever be bright enough or sharp enough to spot with our most advanced instruments is a question that animates both skepticism and fascination in the research community. It is essential, then, to appreciate the balance of humility and ambition in the study of gravastars. No experiment has yet demanded their existence, and the challenge is immense. To differentiate between two objects that, at astronomical distances and scales, are nearly identical in all observable ways. For scientists, gravastars are not simply a flight of speculative fancy. They are part of a broader program to map all that remains possible within, and maybe just beyond, Einstein's iconic theory of relativity, especially in those domains where quantum effects, entropy, and cosmic censorship are forced into uneasy partnership. If the pursuit of gravastars sounds like a quest shaded by equal parts wonder and discipline, that is precisely its appeal. It thrives at the intersection of mathematics, philosophy, and hard observational constraint. The mere possibility of these objects emboldens us to poke at the seams of physics, asking what lies beyond what we can see and how the universe might encode its secrets in the narrow regions where our current understanding breaks down. Perhaps, then, this is the secret promise of gravastars. For all their theoretical roots and observational uncertainty, they help us sharpen our questions about the nature of boundaries, about what it means for information to survive, and about the intricate dance between gravity and quantum fields. They are not, as yet, a confirmed population lurking among the black holes catalogued by our telescopes and detectors, but rather a beacon showing us where our intellectual boundaries are, urging us to be ever more precise, ever more imaginative in how we read the starlight and the silence between the stars. So as you listen, as you follow the possible destinies of massive stars spiraling into gravitational chaos, spare a thought for the gravastar. The third way, the possibility that the universe may occasionally take a fork in the road we have only just begun to glimpse, that beneath the apparently complete script of cosmic collapse, there remains room for revision, room for borders instead of horizons, for returns instead of irrevocable losses, for information restored rather than annihilated. It is this slight, provocative possibility that keeps the study of gravastars as much a philosophical adventure as a scientific campaign, helping us hone the edge of our curiosity and conviction in the face of the universe's seemingly bottomless mysteries. If you let the implications of the gravastar hypothesis settle for a moment, it's natural to feel a gentle unrest, a prickling curiosity about what truly resides behind that nearly flawless mask that, from afar, so exquisitely mimics the most intimidating structures in the cosmos. The beauty in pondering gravastars does not merely rest in the broad concept of a third way, but in the quiet, intricate architecture that makes such an object plausible at all. It is like discovering that an ancient statue, believed to be a single block of marble, is in fact a seamless composite hiding complex inner chambers, each with its own mysteries and subtle engineering. Let's journey inward, together, returning to that precise edge where our quest left off, the imagined forking of cosmic fate, the knife edge where collapse might pause, and physixo, often intent on erasing difference, permits a new kind of boundary to emerge. You and I may easily conceive of grand cosmic objects in broad strokes, but the gravastar quietly invites us to investigate in detail, to explore the microcosms of extreme matter and the contradictions they embody. It's here, in this pause, that you might realize the gravastar's form is less an alternative and more a feat of cosmic carpentry. The closer you look, the more pronounced the subtlety becomes. So what, exactly, resides inside a gravastar? And what, in the strictest terms, separates it from the black holes whose language and law so dominate our understanding of collapsed stars? Consider the anatomy of this cosmic imposter, knowing that it is built from three distinct but intimately cooperating regions, each engineered to address not only gravitational constraint, but the symphony of quantum and cosmic tensions. At its heart lies the strangest of all, the Gravastars' interior domain that, if you could somehow peer inside, might remind you more of the fabric that drove cosmological inflation than the searing density of a neutron star. In familiar objects, as collapse deepens, matter is squeezed to nuclear densities, and then, perhaps, to the mathematical abstraction of a singularity. With Gravastars, this plunge is arrested. Here, deep within, the interior is described not by ordinary matter, but by a vacuum state with positive vacuum energy, what physicists call a de Sitter space. You may recall that vacuum energy refers to the restless humming of quantum fields, even in the absence of particles, a kind of cosmic latent energy, seemingly born from nothing, yet brimming with gravitas in the equations of general relativity. However, there is something even stranger at work. In this inner sanctum, this vacuum energy displays negative pressure. That's a mouthful, but if you imagine the pressure in everyday terms as the push outward against a wall or boundary, negative pressure flips the script, acting not to compress, but to expand. So within the Gravastar, at R values tending towards zero, that is, right at the center, there's a relentless urge to push outward, much like the dark energy we invoke to explain the universe's accelerating expansion. This anti-gravity, in a sense, counterbalances the inexorable inward pull from the star's original mass collapsing in on itself. Now, this inner region could, in principle, be enormous or tiny, but for objects as massive as the supposed progenitors of black holes, the de Sitter core stretches right up to a breathtaking threshold, a mere whisker, sometimes less than a proton's width, from the surface that would otherwise define the event horizon. This is not just an anti-gravitational stew floating inside. Rather, it's a state of matter, more accurately, a state of space-time that flouts our expectations of stuff entirely. It is as if the universe, at this extreme, writes a new rulebook. When pressed too hard, don't collapse, inflate. Of course, without something to restrain this internal expansion, the Gravastar would simply balloon out, dissolving the compactness that makes it so deceptive. Here is where the second component, the ultra-thin but ultra-dense shell, enters the cosmic architectural membrane, defined by exotic properties and extraordinary rigidity. Its equation of state, encapsulated in the phrase stiff matter, tells you that its pressure and its energy density are nearly identical. For every kilogram of mass energy, there's a kilogram force of pressure acting per cubic meter. You might compare this to the surface tension on a soap bubble, but that's an inadequate simile, because even the strongest chemical bonds in ordinary matter cannot begin to reach these intensities. Physically, this shell acts as the perfect traffic cop for the Gravastar's conflicting tendencies. It staves off the outward thrust of the de Sitter core and, in the process, becomes a repository of tensioner place, where the density and energy required to hold the structure together becomes monumental, even if its thickness measures only a fraction of a millimeter or, on a galactic scale, fractions of a kilometer. This thin shell is not simply a boundary in the sense of a solid surface. It is a dynamical, living region, possibly composed of fields or matter forms not yet found in laboratories. Its physical makeup is, as of now, purely theoretical, but its mathematical necessity is clear. Without this wall, the interior would escape. The object would neither be stable, nor would it masquerade as a black hole with any fidelity. Then, as you trace your mind's eye outward, you reach the Gravastar's exterior. What might surprise you is how ordinary this region seems. The exterior is a vacuum, described elegantly by the Schwarzschild solution, the same mathematics that describes the space outside a non-rotating black hole. The gravitational field, the warping of space-time, the speed at which time ticks for distant observersol are precisely what Einstein's equations predict for a black hole of equivalent mass. This is where the Gravastar earns its reputation as a perfect imposter. An observer at a safe distance, measuring orbital speeds or the dramatic bending of passing starlight, finds no difference, no tell, no whisper of the shell's existence. In fact, unless you were able to drop an object almost exactly onto the shell, or pick up impossibly subtle signals of delayed interactions, you would be forced to conclude you were in the presence of a true black hole. Yet, physically, something momentous has changed. The infamous horizon has been swapped out for a genuine Scheller region whose properties, in principle, can reflect, absorb, or re-radiate energy. It is tempting to philosophize, to wonder about the meaning of boundaries here. In most of nature, a horizon is a point of no return, an abstraction unseen except through its effects. A shell, on the other hand, is part of the object itself, the kind of interface familiar to our everyday experience, as in the boundary between air and water, or the rind that marks the border of an orange. This difference might seem trivial when considered abstractly, but it rewrites the rules for what happens to matter and radiation teetering on that precarious edge. If you pause here and reflect, it is remarkable how neatly this elegant design solves some of the central paradoxes of black hole physics. Where does the entropy of such an object reside? In black holes, entropy is proportional to the area of the event horizon mathematical surface with no substance. For gravastars, the entropy is instead distributed in a physical shell, a place where microscopic degrees of freedom could, in principle, hold and process information. This is more harmonious with quantum theory, which demands that, no matter how weird the circumstances, the universe must always keep its books balanced. That information can never simply vanish behind a causal curtain. The gravastar's three-region composition, each distinct yet inseparable, like the layers of the planet Earth, but in far more extreme fashion, writes our thinking about the landscape of collapse. The interior is all about inflationary density and negative pressure, a realm more in common with the earliest moments of our universe than any scrap of star or stone. The shell demands physics beyond the everyday, possibly involving new forms of quantum pressure, exotic states of baryonic or non-baryonic matter, or emergent phenomena at the interface of gravity and quantum mechanics. The exterior stays a model citizen of general relativity, indistinguishable from black holes as far as any remote investigation can tell. If you're now wondering how such a precise construction could ever arise in nature, you are tapping into one of the great frontiers of contemporary theoretical physics. The genesis of a gravastar, in the original proposals, happens precisely where gravity is about to swallow its victim into classic black hole formation. Quantum fluctuations, vacuum polarization, or new physics at ultra-high density could, in principle, trigger a phase transition, swapping out a forming singularity for a seething bubble of vacuum energy. The mathematics works, but whether the universe chooses this path or prefers the grim determinism of the horizon remains open. You might ask, could this entire scenario be dispositive or merely a mathematical curiosity? After all, elaborate theoretical constructions have populated the scientific literature before, only to be sidelined by the blunt weight of data. Yet the gravastar appeals not by overthrowing existing observations, but by sidestepping their limitations. Because its outer space-time mimics a black hole's so precisely, it cannot be ruled out by any measurement taken at a sensible distance. Only by probing right up to the shell, by sensing the very presence or absence of a true event horizon, could you reveal the imposter. And this, so far, is beyond even our greatest machines. Still, the differences, however small, are real in principle. Suppose you imagine dropping a ball from a great height toward what you believe is a black hole. If a gravastar lurks at the center, as your ball approaches the Schwarzschild radius, its journey would change. Instead of disappearing across an event horizon, never to return, it would, after interminable time for a distant observer, crash into the shell, perhaps shattering or triggering local oscillations, perhaps producing a faint, time-delayed echo. While the distinctions are breathtakingly subtle, they are encoded in the physics ready to be discovered. If only we can hone our telescopes, build our detectors, challenge our preconceptions. This construction also establishes that the gravastar is stable, at least under the right circumstances. Theoreticians have shown that the equilibrium between the shell's tension and the de Sitter core's pressure is not necessarily fragile. There are, to be sure, dangers, perturbations, anisotropies, or deviations from spherical symmetry could, depending on the properties of the shell and the nature of the vacuum inside, destabilize the whole structure. This is where discussions become deeply technical, full of calculations involving the Israel junction conditions, matching the space-time across different surfaces, ensuring the object won't bloat or shrivel at the faintest touch. But these are not merely mathematical crutches. They are essential demonstrations that the proposal is not wishful thinking, but a viable, if rare, configuration of mass and energy. As you follow this train of thought, it's perhaps the shell, the ultra-dense, ultra-rigid layer sandwiching the de Sitter core that most fascinates theorists and daydreamers alike. What might it be made of? Could it host exotic forms of matter, akin to what some speculate existed microseconds after the Big Bang quark-gluon plasma, color superconductors, axion stars, even more exotic breeds? Or is it instead something profoundly quantum, the manifestation of entangled quantum fields caught at impossibly high densities, expressing their resistance to further compression in a tension so fierce that it rivals, atom for atom, the strongest bonds in the universe? The mathematics leaves options open, but insists that, whatever the composition, this shell is thin, tense, and perfectly poised. There is, however, an even deeper drama playing out at the boundary, involving energy, information, and what it means for something to fall into a gravastar. If you throw a particlea, more realistically, let an accretion disk trickle hot, ionized gas toward the object, the shell must, in some way, respond. Does it heat up? Does it ring, transmitting vibrations as seismic waves across the cosmic bubble? Does it emit bursts of radiation, or perhaps, owing to its immense density, simply absorb and store the energy, slowly leaking it back as soft photons? The theoretical playground here is immense, but the principle is clear. The shell is active, a place where physics does not stop but rather becomes a conversation between inside, outside, and surface. Moreover, this structure supplies a convenient laboratory for thinking about quantum gravity, an attempt ever at the edge of physics to unite general relativity's cosmic largesse with quantum mechanics' intimate granularity. Here, the Gravastar, by avoiding horizons and singularities, dodges the places where our equations break down, instead proposing a region that, while exotic, is still describable by well-behaved mathematics. In this light, the object serves a dual purpose, not only as a possible astronomical reality, but as a blueprint or testbed for fundamental theory. What about variations in this template? While the archetypal Gravastar, as described by Mazur and Motteler, relies on the classic general relativity, recent years have seen a flourishing of designer Gravastars, contemplating modifications to gravity itself. In scenarios inspired by string theory, quantum gravity, or modifications to Einstein's equations, think of terms F, R, T, F, G, T, and so on. The structure of Gravastars might admit small variations or stabilizing features that make them more likely to arise or survive. These versions remain speculative, yet share the heart of the matter, the defining interface, or shell, marking a transition between an exotic inflationary core and the mundane vacuum of outer space. It serves you well to ponder the distinction between a horizon so absolute as to define the very boundary of what can be known and a shell, which, despite its alien nature, remains a kind of physical place, an interface that could potentially interact, reflect, absorb, or leak. This is not merely an academic debate about surfaces. It is a live question about what it means for nature to keep its secrets, to conserve or recount the stories of matter and light that wander to the precipice of eternity. And so the anatomy of the Gravastar, that nearly perfect mimic, emerges as a threefold entity. At its center, a quantum storm of negative pressure and positive vacuum energy. Encasing this, a shell so dense and taut that it challenges our conception of matter and energy, and outside, the placid, mathematically unremarkable but physically consequential field of a Schwarzschild vacuum. Each region is necessary move or disrupt one, and the object collapses, dissolves, or explodes. All three together allow nature, in principle, to circumvent the finality and loss that event horizons demand. Let your thoughts return, then, to the soft but resolute lesson here. The Gravastar, in its architecture, stands not so much in defiance of the black hole, but as its mirror cosmic what if, built with all the artistry and constraint of general relativity, quantum theory, and our most audacious thought experiments. While the path from supernova remnant to Gravastar remains theoretical, the journey into its anatomy takes you to the very boundary of current physics, where, Imagination, mathematics, and observation await their next act. If you find yourself feeling awed or restlesser, perhaps eager to add your own what-if to the grand experiment, pause and notice that you're not alone. Every breakthrough in science began, after all, with a willingness to ask, what if the current catalogue of endings is not complete? What if nature, always more creative than our settling minds, yet has a few more tricks at her disposal, waiting for moments of radical insight or the next round of sharper telescopes and deeper theories? If this meditation has sparked something in you, a question, a spark of skepticism, a moment of awe, share it in the comments, knowing that the questions you raise may guide where curiosity, and perhaps discovery, leads next. Think for a moment. Would you trust the surface beneath your feet if you suspected, as you do now, that between you and the abyss there might be not nothingness, but a shell-vibrant, fierce, teetering forever at the edge of what the universe allows? And if so, what would you do, now, with that new frontier shimmering in the corners of your imagination? Perhaps, as you linger in the liminal space between wonder and scrutiny, you notice how these layered possibilities drift over your thoughts like a gentle mist, both intriguing and unsettling in their indeterminacy. If you are at all like me, the contours of this invisible shell, this mysterious edge, inspire a unique kind of vigilancia sense that even the most ordinary-seeming cosmic vistas can shelter extraordinary secrets. Your mind, maybe, begins to imagine what it would mean to actually detect a gravastar, what signs would whisper their difference amid the chorus of phenomena that populate our catalogues of black holes. Let yourself settle into this question for a moment. From some safe vantage in interstellar space, peering across distances so immense that even the power of imagination grows silent, you see before you the signs of a compact, massive object, matter spiraling inward as a luminous disk of gas, flares erupting in X-ray light, stars trapped in tight orbits that defy the logic of soft, ordinary gravity. All of it feels familiar. This is what astronomers have seen countless times when probing the hearts of galaxies. Now, pause. Imagine that this restless object, so immense as to be measured in millions or billions of solar masses, is not a black hole, but a gravastar. The first and perhaps most humbling realization is that your evidence, so far, is perilously thin. Both objects, viewed from afar, parade the same disguise. It is almost as though the cosmos itself toys with us, offering only subtleties and refusing anything so plain as a signature or a telltale mark. You become attuned to the art of patience, waiting, observing, letting the smallest details accumulate, like a paleontologist reconstructing ancient giants from a few scattered teeth. Would anything, truly anything, in all this noise and fury, tip you off that what lives at the core of these scenes is a gravastar, and not the event horizon and singularity you have been told to expect? This is where you must allow the narrative to become both precise and contemplative, because the answer, if it exists at all, hides in the minutiae of motion and light. Begin, perhaps, by sinking into the world of orbits, those perfect ellipses and swirls that stars, plasma, and light itself inscribe around these dark centers. Here you would find profound commonality. The paths of things orbiting a gravastar are, to all measurable precision from afar, indistinguishable from those that would encircle a traditional black hole. The mathematics that determine the placement and speed of those paths emerge from the same solution, Schwarzschild's famous blueprint, or, for spinning bodies, the Kerr solution. Such is the fidelity of the gravastar's external field that even pros with decades of observation find no easy target, no flag marking a difference. Light bends around both, forming the same sharp distortions and the same long arcs of gravitational lensing, a mirror perfection that almost feels mischievous. Maybe, in your heart, you hoped that jostling a little harder, measuring a little finer, would unearth evidence. But every time a hotspot, a swirl of infalling matter, carves its orbit at fractions of the speed of light just above the event horizon, just above the shell, what emerges on your detector is a blurred echo of precisely what's expected from a black hole. The universe, it seems, understands costume design better than we do. In the feverish race of discovery that characterized the first 2 decades of the 21st century, the shadow of the black hole became a media spectacle and a scientific prize. The Event Horizon Telescope, an array that links observatories around the world in perfect synchrony, allowed humanity to glimpse, for the first time, the silhouette of a supermassive black hole in the galaxy called Messier 87, and later, at the heart of our own Milky Way, Sagittarius A star. The world looked on, astonished, as images flickered onto screens across continents, a soft, nearly circular ring encircling a dark center, testament to the ferocity with which gravity bends even photons into obedience. Yet, if you attend closely, you discover something quietly unsettling. That shadow, that very ring announced as incontrovertible proof of horizons and singularities, is, in fact, far less discriminatory than one would hope. The fundamental physics is mercilessly impartial. Any object, with enough mass squeezed under the right compactness, will whip light into that same shape. A gravastar, hugging the critical radius with its shell, can make a shadow so convincing that neither eye nor algorithm presently deployed can decree its difference from a black hole. How much more humbling can physics be? Let that realization settle for a moment. Think of it as the cosmic equivalent to recognizing that two well-dressed strangers at a party, both polite, both quiet, are so similar that only their most intimate friends might know them apart. The ring you see, the famous photon sphere, is determined not by the presence of an event horizon, but by the warping of spacetime outside the object. A gravastar copies this precisely because its exterior is indistinguishable from the Schwarzschilder, if spinning, Kermetric. You might then try to coax out differences by looking at the finer structure of the luminous matter around these objects. Astronomers observe swirling disks of gas, the so-called accretion disks, spiraling inexorably inward, heating to incandescence, sometimes outshining entire galaxies. Within these turbulent maelstroms, clumps of plasma, hotspots, as they are affectionately called, illuminate, orbit, and ultimately vanish, all governed by the iron rules of general relativity. If only, you might hope, something about their flickering their brief lives and sudden disappearances could betray the secret of the shell versus the horizon. Yet, within the skin of uncertainty allowed by present data, the behaviors recorded for black hole candidates are again perfectly compatible with the gravastar blueprint. The outbursts, the flickering, the savage brightness, the abrupt quiet, these are precisely what the theory of accretion predicts for both shells and horizons, provided the shell sits ultra close to the Schwarzschild radius. But what about the jets, those beams of matter and radiation launched at nearly the speed of light, piercing the interstellar medium and announcing with breathtaking arrogance the presence of invisible monsters? Here, too, the equations are wry. The existence and strength of these jets depend not on the horizon, but on the physics of magnetic fields and turbulent disks outside the critical radius. Whether the interior is a one-way portal or a fierce shell of vacuum and tension makes little difference. So long as the exterior curvature and rotation are right, jets can blaze forth with perfect mimicry. Even their polarization signatures, the delicate dances of electromagnetic waves in the tortured space around spinning compact objects, so far refuse to distinguish between the abyss and the shell. There remains a quiet poetry in this, a cosmic lesson about identity and disguise. Perhaps you have known someone whose depth of character was nearly impossible to discern from their outward appearance, whose public mask was worn with such perfection that only years of intimacy could glimpse the truth beneath. A gravastar presents that kind of challenge to astronomers. Investigators are left probing the faint echoes, the smallest anomalies, the most delicate ripples in the symphony of gravity, heat, and light. This endeavor, sometimes, can feel overwhelming. Every measurement brings you closer to the realization that what separates the gravastar and the black hole is not a matter of obvious signals, but of philosophical and technical subtlety. There is, perhaps, a faint hope left in pursuing what physicists term dynamic and thermodynamic, signatures the possibility that under the fiercest scrutiny, the timing and spectrum of emissions, the quirks in orbital precession, or the briefest echoes in brightness, could, finally, offer a distinction. But here, too, humility is warranted. The turbulence of the infalling plasma creates noise and confusion, masking any signature a shell might leave. The shadows remain crisp, the jets bright, the orbital motion on time. The thermodynamics, while a bit of a question if superfine detail could be extracted, have not, to date, forced a deviation. Scientists, in their continued patience, have extended the search for difference into the ringdowns following merges those fleeting phases after two compact objects collide and merge, when the result rings out like a struck bell, radiating gravitational waves across the cosmos. The expectation was that if a shell existed, it might reflect a sliver of gravitational energy back and forth inside the cavity, yielding echoes whose regularity and persistence would signal a physical surface rather than an event horizon. Here too, the jury is very much still out. The data, to this day, is noisy, ambiguous, and fiercely debated. What remains remarkable, and perhaps a bit sobering, is that all these approach shadows, orbits, jetted fire from hidden engine shave, in the balance, only serve to emphasize the perfection of the Gravastar as an imposter. It is a testament to the old lesson that when you seek the truth about the deep, distant universe, there will always be facets left undecided, signatures left unclaimed, mysteries held tight behind perfect camouflage. Let this be an encouragement as much as a challenge. The story is not one of hopelessness, but of partnership, of theoretical insight urging observation onward, and observational patience scouring the universe for clues. You might, as you meditate on these objects, feel drawn to the very limit of resolution, to ask, what would it truly take to know? Would it be the first detection of a flicker just past the photon ring, a subtle deviation in the shape or lag of a hotspot, some faintly delayed flare that signifies not annihilation but rebound? Would it be a new generation of telescopes, or a new technique in time-resolved astrophysics that finally separates the horizon from the hidden, active shell? Science, and you as its witness, are invited to linger in these questions, knowing the difference, if it is ever discerned, will come only by stacking observations, sharpening instruments, and, above all, quieting your need for immediate closure. There is almost a philosophical resonance to this searching, just as in life, where the boundaries between mask and truth, surface and core, are both vital and elusive, so too in the astrophysical theatre do we meet the impossibility of easy answers. If you pause, considering your own longing to be sure, your desire to point and say, this is a gravastar, not a black hole, you are admitting your kinship with every scientist who ever watched a star flicker, a shadow move, a jet twist, and yearned for just one unambiguous sign. Yet perhaps the virtue is in the lingering, in continuing to look and to refine. Allow yourself to soften into this realization. Maybe, just maybe, the cosmos prefers subtlety. Perhaps it delights in allowing two fundamentally different solutions to appear, for now entirely equal on their stage. Only at the limit, only at the very edge of discernment, might the difference become visible. And at that edge, you are present not merely a passive watcher, but an active co-creator of meaning, drawing philosophical inspiration as much as scientific pleasure from the search. I invite you to reflect, to imagine the awe of standing before two doors, uncertain which conceals a horizon and which a shell, knowing that you must decide with all the delicacy and patience the universe asks of us. And if the quiet of the night leaves you restless, pondering what more could be seen, how much closer you could look, or deeper you could listen, share it. Let this curiosity be a lantern for others who, like you, feel the gentle weight of the unknown and welcome its embrace. Let your thoughts, as you nestle in the dark before sleep, wander to the edge of the cosmic mask. Let questions linger, for in them rests the possibility that what seems identical, given enough care, will one day be known for what it truly is. In the meantime, you and I dwell within the Mysteria mystery, made all the richer not by answers but by the patient, artful act of looking, again and again, into the shadowed heart of the universe. If you allow your mind to dwell at the threshold of the cosmic masquerade, you soon realize that the search for difference, the longing to know whether you are gazing upon a shell or a horizon is not just a technical puzzle, but also an invitation to rethink your relationship with the subtle and almost indistinguishable. You are drawn, almost magnetically, toward the edge. Not the splendid center stage where radiance explodes in obvious gestures, but the fragile borderlands, the margins where hints must be sifted from tumult and silence can shimmer with hidden structure. It is in this clandestine, uncertain zone surrounding the shadow of the Gravastar that your patience is most needed, and where the promise of revelation, however, faint must be kept alive by the smallest, most stubborn phenomena. Imagine then that you find yourself drifting closer, with your senses tuned not only to the blunt signals of light and shadow, but also to the gentle whispers that might distinguish a shell from the one-way curtain of a classical black hole. You begin to wonder if the Gravastar has a surface, a tangible border, even if it glows not by choice but by necessity. Could there exist moments, brief and nearly imperceptible, in which its difference calls out? These are not the barked commands of cosmic jets or the tirelessly repeated story of orbital motion, but rather the soft echo of impacts, the faint delay in a dance of light, the spectral note of something returning from the brink, evidence that energy does not always vanish, but sometimes rebounds, transformed or magnified, from a surface that most of the cosmos believes does not exist. Perhaps, in your reverie, you become aware of the accreting material, the plasma and gas that crowds near the critical radius, glowing in X-ray flares, radiating heat as it loses energy to gravity's embrace. In black holes, this energy has but a single fate: when matter crosses the event horizon, it is consumed, its warmth and motion rendered invisible, its story clipped and ended without remainder. But if the Gravastar sits in place, proudly holding its border just beyond the Schwarzschild radius, what, then, becomes of that energy as it falls? Here, you must consider with care the kinetic energy, the heat, the organized swirl and tumult of falling matter must at last confront a barriera physical shell. Energy does not simply disappear, it confronts the shell's surface, and physics demands a response. You now stand at the center of one of the subtlest and most beautiful possibilities in modern astrophysics, a scenario in which light, instead of vanishing, endures a kind of near death, and against all odds is partially returned. If you could watch with infinite precision, you would see not the utter silence of absorption, but rather a performance of light. A fraction of the energy is re-emitted, not instantly but with delay, after being partially trapped, perhaps subjected to complex interactions with the shell's tremendous density and exotic properties. Some photons may be reflected, some thermalized, some scattered in directions that speak of the shell's nature and composition. This surface, so hauntingly close to absolute dissolution, becomes an active participant, and it is this activity, a subtle, time-delayed glow, a recycling of brightness, that could offer, at last, a first real clue. You might feel, as you listen, the stillness of true anticipation. For in this encounter, the differences are minute, existing as the soft shimmerings of echo's light returning to the observer after a tiny but crucial time lag, dictated by the gap between the photon orbit and the shell's boundary. These echoes are not boisterous events, but tremulous, often overwhelmed by the noise of the accretion disk. Yet, with sufficient patience, with series of observations stacked over long intervals, an observer trained in the art of discernment might one day witness a faint pulse trailing just behind the primary brightness, a signature, not of loss, but of return. Think of the superheated plasma that rushes toward the core, drawn by gravity's insistent call. In a black hole, its journey ends at the horizon, final and absolute. In a Gravastar, it smashes into the shell, triggering a brief and complex conversation. Some energy is inevitably lost, absorbed by the shell, but a residue is propelled outward. How might you measure the difference? In the maps of brightness, in the choreography of flaring hotspots, in the precise timing and spectral coloring of light as it appears, fades, and then, almost imperceptibly, reappears for a final act. These are the fingerprints of a surface that refuses to be silent, even as the broader cosmos mistakes it for a void. You are reminded that the game, at this edge, is not simple. The accretion disk is a noisy, violent, stochastic environment, filled with turbulence, shocks, magnetic fields reconfiguring themselves in moments, and particles accelerated to velocities near the speed of light. In this simmering chaos, the difference between absorption and emission may be smeared, the echoes buried in the static. Nonetheless, the task is not hopeless. Modern astrophysics does not rest on a single snapshot, but on the accumulation of elaborate data curves of light, time-resolved maps, multi-wavelength signatures captured from a universe that seldom offers repetition. If you were to focus on the specific scenario of a thin-shell gravastar, the possibilities become even more riveting. The shell, situated just outside the innermost stable circular orbit, the boundary, where matter can swirl only a final time before plunging inward, has the opportunity to interact with both photons and plasma in ways wholly unlike the consuming abyss of a black hole. Simply put, energy can bounce. In the model's most optimistic portrayal, an X-ray flare, birthed from matter on its fatal dive, may re-emerge after ricocheting off the shell, delayed and softened, the spectrum perhaps changed, the signature altered by its intimate brush with exotic physics. As brighter and more agile telescopes emerge, these subtle temporal echoes grow closer to detection. The theoretical foundation is solid, the hope tenaciously present. Maybe you pause, now, reflecting on the meaning of an active border at the heart of such objects. For while the abyss of a black hole delivers existential finality, the shell of a gravastar enacts a quieter drama. Most of the time, it is a keeper of silence, swallowing energy with little protest. Yet in rare moments when observed with sufficiently sensitive instruments, it admits the possibility of reflection, emission, perhaps even resonance. Some models predict that if the shell is not perfectly absorptive, it will behave like a cosmic drumhead, ringing ever so briefly with the impact of infalling matter or light. The vibrations carry information, faint but genuine, about both the shell and the universe it inhabits. Let us meditate for a while on these possible resonances and their significance. Pause for a moment and imagine a clump of plasma, rolling at nearly the speed of light, plunges inward, strikes the shell, and imparts a fraction of its energy, much as a pebble dropped onto a taut membrane would set the surface trembling. To a distant observer, a soft, time-delayed brightness arises not as a perfect copy of the original, but coded according to the hidden symmetries and stiffness of the shell. If these vibrational echoes are present, and if you are patient enough, you may find that their recurrence is a living record of a border long-presumed absenta song in the darkness that belies the myth of silence. This is not, of course, a trivial detection. The time lags involved are astoundingly brief, often measured in milliseconds or microseconds, dwarfed by the chaotic variability of the plasma around the gravastar. The signals mix and fade in the sheer cacophony of accreting matter, but with each new generation of instruments, the hope sharpens, perhaps with datasets accumulated over years, with clever pattern recognition and statistical courage, the universe will at last yield an echo that no black hole could plausibly generate. You might imagine, too, more refined signals, the microdifferences in the brightness just inside and just outside, the famous shadow, the subtle shifts and harmonic overtones in the spectrum, all of which may encode the presence of a shell. Machine learning, now rising to prominence in observational astrophysics, stands as a patient partner in this work, scanning vast archives for recurring time lags, spectral deviations, or subtle non-thermal signatures. Increasingly, our role is not merely to capture light, but to decode its afterglow, every faint sparkle, a possible messenger from the border, every missed flicker, a reason to redouble attention. In your own nightly practice of thought, you might let yourself reflect on the philosophical meaning of such a picture. In a universe renowned for erasing certainty, for hiding its deepest secrets in seemingly implacable shrouds, is it not comforting to imagine that even at the threshold of annihilation, some energy persists, some echo remains? The Gravastar, with its shell, asks you to linger in hope that when all appears lost, there is always a border, however faint, at which the universe admits its resilience. You are called, in this inquiry, to value patience above all else. The detection of echoes, or subtle time lags, requires not just clever technology, but also the willingness to observe with discipline, to accumulate light curves, to build up maps of phase and emission that only reveal their secrets under prolonged, focused examination. The rewards of that patience, should they come, would be profound. Not just the vindication of theory, but a new phase in our understanding of extreme matter, information flow, even the fate of the cosmos's rarest collapses. Consider the lesson that emerges quietly from all this. The Gravastar, which may guard its secret for eons, leaves you with an existential invitation. If the difference between oblivion and return, between final silence and subtle echo, hinges on a shell the breadth of an atom, then the boundaries you encounter in every sphere of life, boundaries between thought and action, hope and resignation, loss and memory, deserve that same careful attention. The cosmos, it seems, loves edges, and most of all, the active ones. So I invite you, in these final moments, to contemplate what it means for the most extreme engines of cosmic drama to possess active borders rather than depths of absence. Let yourself imagine the future, where films of accretion disks are rendered with glorious cadence, where machines and humans in partnership tease out the slow, persistent return of light that speaks not of endings but of transformation. When you next look into the night and feel small against the breadth of space, remember, the truest clues are often those that shimmer just beneath the threshold, waiting for eyes patient, hearts open, and minds attuned to the possibility that what once seemed final may, mysteriously, return once more. And as you reflect before sleep, let the possibility of the active border settle in your imagination. What evidence would convince you? If you held in your hand a light curve flickering with echoes, would you be swayed by a microsecond delay, a spectral anomaly at the edge of a shadow, a whisper that proves a shell where all others found only emptiness? Share your wonder, your doubts, your meditations. Let them ripple outward, an echo of curiosity connecting you not just to the stars, but to the quiet hope that even at the edge of the ultimate abyss, the universe still knows how to sing. As you let the idea of active cosmic borders echo within you, these poetic whispered confessions from the edges where most assume silence, you might notice that your mind naturally drifts further, toward even subtler forms of listening. There is a gentle challenge here, a sort of invitation from the universe itself, to consider whether all of its music is meant for your eyes alone. Sometimes it is in the silent vibration of space itself, a ripple in the deep fabric of reality, that the cosmos tells its most intimate stories. The language of light, even with its softest delays and faintest echoes, is not always sufficient. Occasionally, what you need is a new sense, entirely a quiet sense of vibration, of gravity itself humming after a titanic collision. And it is precisely in this borderland where matter, energy, and the silent undulation of space converge that the next chapter of the Gravastar question comes alive. Imagine, for a moment, that you are standing at the intersection of myth and mathematics, where not only photons, but the very essence of space-time plays its part. When vast objects, black holes, or perhaps Gravastars, spiral toward each other in the ultimate embrace, they merge in a moment of violence beyond ordinary understanding. The collision unleashes waves of gravity that pass through everything, changing the very widths and lengths of space as they go. These are gravitational waves, the cosmic equivalents of water's ripples, but passing silently and without resistance through the universe, carrying messages that have nothing to do with light, but everything to do with the presence and structure of the deep. Now, quiet your mind for a while and imagine listening for such a wave. In the years since the first revolutionary detection by the LIGO and Virgo observatories, gravitational waves have become a new melody in astronomy, a signal heard not with eyes, but with supremely sensitive recordings of distance and time. When two compact objects merge, the finale is not merely a crash. It is a performance, a fading bell, whose notes, the ring down, are rich with information about the kind of object that now exists, where once there were two. This ringing, modulated by the properties of the final remnant, is determined by the very nature of its border. Now, the gravitational music, much like the echoes in light you pondered before, holds clues that can potentially distinguish a gravastar from a black hole, if only one listens carefully enough. Imagine, then, what might occur if the cosmos does not seal the final remnant inside a perfect horizon, but instead leaves a shell, a reflective border, just beyond the abyss. When black holes merge, the newly formed object is expected to ring down with a specific spectral signature defined by its mass, spin, and the exact geometry of its event horizon. Every note damps away, with energy leaking inexorably into space until the disturbance is gone. Here, the classical expectation is brutally absolute. The horizon soaks it all in, no echo ever returns. The exterior universe is forever forbidden to hear another word from inside. However, if you substitute this horizon for a physical sheller, Gravastars' defining feature things change in a manner as subtle as it is profound. Now, the shell can reflect or reprocess some gravitational energy. As the newly merged compact object vibrates, some of the resulting gravitational waves do not simply fall into an endless abyss, but instead bounce between the shell and the unstable photon orbit just outside. This creates the potential for a train of faint echoes, each diminishing in amplitude, each delayed by, perhaps, fractions of a millisecond or longer, depending on how close the shell lies to the Schwarzschild radius. If you are sufficiently sensitive, patient, and undistracted by the chaos of noise, you might glimpse those echoes, like the aftertaste of a symphony's last chord, lingering quietly in gravitational silence. You may sense the poetic tension in this search. All of the universe's grand violence colliding stars, crashing black hole lookalikes, has been reduced, in our age, to measurements of millimeters on detectors that lie silent and still on our own blue planet. LIGO and Virgo, with their arms kilometers long, strain to capture these ripples. The signature you would seek, if gravastars do exist, would not be the initial cry of merging giants, nor even the bell-like note of the newborn object, but instead the faint, repeated whisper of energy returning, each delay measured by the brief sojourn of a wave between the shell and space beyond. You are called to an act of incredible discipline, differentiating an echo in the ocean of noise, finding memory where the cosmos seems determined to ensure forgetting. There is a kind of intimacy in this. Pursuit astronomers and physicists have learned to commune with noise, to trust no single signal, to demand that patterns repeat again and again in a catalogue of cosmic events, if they are to be believed. In recent years, dozens and then hundreds of mergers of black holes and neutron stars have been recorded. Inside those archives, some researchers have sought, with both hope and caution, signs of echoes, looking for repeated structures, fluttering tales of energy, notes out of place after the expected ringdown. The honest story, shared between colleagues late at night and reflected in careful scientific papers, is one of both longing and restraint. Early reports, fueled by excitement, claimed the possible detection of such echoous subtle halfway visible structures in a handful of events. Yet, with time and with the discipline of science, many of these supposed discoveries have faded. When analyses have been repeated with stricter criteria, when blind searches have been performed, the echoes have become fainter, mostly swallowed by that great ocean of detector noise that is never truly random, never truly clean. Those moments of almost discovery become cautionary tales, reminders that wishing for signatures is not the same as finding them. Still, do not let that sobering tone cloud your meditation. Rather, use it as a grounding touchstone. Science, at its very best, is rarely about instant vindication. It is about the slow, stubborn sifting of possibilities, the insistence that reality, however subtle, must yield to evidence. The current consensus is clear and honest. Systematic searches for gravitational wave echoes, especially with large numbers of events accumulated between the years 2016 and 2023, have not found statistically significant, repeatable evidence. The pattern, the train of echo pulses you would require to claim, at last, that a surface replaces a horizon has yet to appear, no matter how insistently one listens. Contemplate for a moment the beauty in this method. Imagine how a physicist sits with hundreds of ringdowns, normalizing, stacking, analyzing, searching for signals. In this work, the presence of a real echo would be transformative. But to guard against enthusiasm, a real echo must be seen not only in a few events, but across many, with predictable delays and damping tied unambiguously to the mass and radius of the compact object. False positives, the ghosts conjured by instrumental hums or statistical fluctuations, must be unmasked. Such is the relentless rigor of listening to the cosmosone must need the difference but refuse to invent it. You could also reflect on what the detection of echoes would mean for your understanding of the universe. In a simple black hole, the information, the chaos of merger, is swallowed for good. Only the immutable parameters persist. If echoes were confirmed across many events, their existence would force a reckoning with the very idea of a horizon, suggesting that some, or even many, cosmic collapse events do not end in perfect silence, but in a muted conversation between energy and a shell, a dancing partnership in which gravitational waves, like photons in the models considered before, sometimes return. To ground yourself further, think about just how delicate this task remains, despite the enormous energies involved. The time delay for an echo in a gravastar with a shell only a handful of Planck lengths above the critical radius might be milliseconds or less. The amplitude, already dwarfed by the initial signal, diminishes swiftly. The detectors themselves must overcome not just interference and instrumental drift, but also the colored noise of their environment. Distant thunder, traffic hundreds of miles away, even the quantum fluctuations of their own lasers. Standing on this frontier, it is easy to become humbled by both how much we can now hear from the universe and how much still escapes our grasp. Yet you are not left hopeless. The story, for now, may be one of non-discovery, but it is not one of closure. New generations of detectors both on Earth and, soon, in the quiet reaches of space promise to plunge deeper into this gravitational song. LISA, the Laser Interferometer Space Antenna, is planned to fly in the next decade, tuning itself to lower frequencies ideal for supermassive objects. With detectors of higher sensitivity, with longer observing runs, with faster computers and algorithms that learn from every previous attempt, the search for echoes remains vibrantly open. Each year brings more data, more chances, more discipline. The silence of confirmation so far is a discipline, a shared promise that the question shall still be asked. This speaks, in a way, to how you might live with mystery in your own life with questions that deserve both longing and patience. Each echo not found is not a failure, but a boundary that says, not yet, not in this way, not in this place. It demands an openness to possibility, but also a serenity in waiting, a delight in the persistent asking. You are encouraged, then, to think of these searches for gravitational echoes as a model for your own watchfulness. Nothing truly significant is discovered in a single burst. The truest answers are built from recurrence, from patterns revealed only in the accumulation of effort and time. What LIGO, Virgo, and soon LISA offer are ways of attuning yourself not just to the loudest voices, but to the quiet, repeated aftermaths, those moments when the universe, perhaps, lets something return from the border, when silence itself is not final but dappled with a recurring memory. Reflect gently as you drift towards sleep on what it means for reality to offer no perfect closure. The lack of echoes, thus far, is not a negation. It is an invitation, the border where science and patience meet. The echoes, should they one day sing clearly, could redefine horizons not only in mathematics and physics, but in your own philosophy. In every waiting silence, in every careful search for meaning, there sits the persistent possibility of return, a possibility that honors both longing and discipline, shadow and the hope of resonance. Let this inform your wondering, your patience, your willingness to find beauty in both presence and absence. And, if you feel compelled to do so, I invite you to share your own thoughts or questions below. What would it mean for you if the echoes at the edge of gravity, after so many silent tests, finally rang out a persistent memory of cosmic borders, a hint that nothing is ever truly lost? Let your reflections be an echo, a signal passed softly outward, as we all continue this listening together. And so, as you dwell in the deep silence left behind by unclaimed echoes, you may begin to sense the quiet patience that defines both scientific inquiry and the more contemplative passages of your own life. The absence of an answer is its own invitation, a softly illuminated corridor gently suggesting that some questions, like subtle fragrances or distant music, can only be approached by indirect means. Sometimes you do not hear the echo, not because there is nothing to return, but because the listening has not lasted long enough, or because the instruments you use are just on the edge of sufficiency. You recognize in this patient act the essence of astronomy's deepest wisdom. Nature's truths are revealed only to those who can both withstand prolonged uncertainty and delight in a gradual unfolding. So let your attention settle gently now on the next frontier to which such patience leads you. The question of surfaces, whether at the beating heart of the galaxy or in the crowded cores of other galaxies, the universe offers any bright, thermal protest against the idea of the perfect abyss. When silence greets your gravitational ears, perhaps you should look again with eyes attuned to heat, to the glow of matter as it hurls itself toward what may or may not be an abyss. Consider the profound simplicity of this. If a border truly existeth, rather than surrendering into nothingness, some physical shell greets the infalling matter, then the universe should, at some deep level, betray itself by shining. It is a quiet hypothesis, yet one with the persuasive power of a riddle that feels almost too elegant not to be true. Wherever there is a surface, there is the possibility of heat, of emission, of a kind of elemental protest against entropy and oblivion. So, let yourself walk with the astronomers who have, for more than a generation, turned their most sensitive instruments toward the supermassive heart at the center of our own galaxy Sagittarius A star. They measure not only the orbits of stars swirling close to this darkness, not only the gravitational signatures of something remarkably compact, but crucially, the light and heat that would betray the presence of any kind of luminous surface. And as your mind lingers here, ask quietly, if there was truly a shell, a reflective or absorbing border, would the center of our galaxy be shining not just in the fleeting flashes of jets and flares, but in a stubborn, persistent, thermal way, like an ember that refuses to be fully smothered? Let the implications of this sink in. In the case of a classical black hole, the fate of infalling material is absolute. Once crossed the event horizon, all hope of return is lost. All energy disappears save for the faint, theoretical wisp of Hawking radiation, a process so vanishingly slow for astronomical black holes that the universe itself will have faded long before it becomes significant. Light, heat, informational are claimed by the gravitational void, leaving only the broadest parameters to be inferred by distant observers. The silence of the black hole is nearly perfect, broken only by accidental collisions in the surrounding accretion flows, or by the universe's own background noise. But now, with your contemplative mind, envision the alternative: a gravastar, or any compact object with a physical border. Think of what must occur when matter, from interstellar dust to entire stars, is drawn inexorably inward. As the material is compressed and heated in the accretion disk, it radiates with all the drama of a cosmic forge. But in the last act, if there is a surface, the matter must crash to a halt. Its kinetic energy, its internal heat, cannot simply disappear, cannot slip silently past a metaphysical curtain. Instead, this border, however thin, must respond as every surface does. It must, in accordance with the basic laws of thermodynamics, radiate heat. It must glow. Pause to reflect on the starkness of this prediction. The energy of infall is not subtle, not a minuscule aside. Across years and decades of observation, astronomers estimate the rate at which matter should plunge toward these galactic hearts, the drip and roar of interstellar debris, the sometimes sudden buffet of disrupted stars or gas clouds. They calibrate their expectations not on mystery, but on the trustiest equations of energy and flux. Given a known rate of accretion and a physical surface, the resultant thermal glow should be both immense and, in many wavelengths, inescapable. Sagittarius A star, at the center of our own galaxy, would become a lighthouse in the millimeter and infrared sky, a beacon demanding attention, a challenge to all theories of silent collapse. Yet, as the years pass, with countless hours devoted to monitoring this cosmic core, the anticipated light simply does not come. The measurements remain stubbornly dark, save for brief flares and turbulence in the outer disk. No persistent, strong, thermal emission, no evidence of a surface ablaze with the energy of countless falling fragments is observed. The universe thus whispers something profound. If there is a border, it is either utterly dark, so perfect an absorber as to defy established physics, or, perhaps more simply, there is no surface at all. The argument, as it quietly accumulates, weighs ever more heavily against the possibility of luminous shells. This finding is neither dramatic nor the product of a single spectacular discovery, but rather the slow, careful accretion of non-events, a catalogue of absences. The silence itself is the evidence. The brighter the predicted signal from a hypothetical surface, the more its continued non-appearance squeezes alternate theories into increasingly constrained and awkward accommodations. Could there be a shell, yet so astonishingly dark as to absorb all infalling energy, with no re-radiation at all? Could magnetic fields redirect the energy? Could the geometry of the accretion somehow conspire to hide the heat? Each possibility, explored in depth, creates more tension, more scientific uneasinone, satisfy the principle that energy, when stymied, must ultimately reveal itself. You might find, as you contemplate this, a parallel between this cosmic investigation and the quieter, daily sifting of truth in ordinary life. Sometimes what isn't said, what isn't seen, becomes the center of meaning. Silence, a persistent absence, shapes the story as forcefully as any bright declaration. In the deepest part of the night, the absence of warmth at the galactic core becomes a soft proclamation. Not everything can be hidden, and what ought to be present but isn't reveals just as much as what blazes in plain sight. The wisdom of this approach does not exhaust itself in a single case. Outside our own galaxy, astronomers have trained their eyes on the cores of distant galaxies, on other radio-bright behemoths, on the calm and active alike. In all these cases, where the rate of matter accretion can be deduced, where the geometry and orientation of disks can be mapped, the same sharp question is posed. Does the object emit all the energy it ought? If a surface is there, the answer comes back, again and again, cloaked in absence. Objects assumed, on mass and radius alone, to be black holes behave with the same sullen silence. The missing thermal light, the unbroken darkness at wavelengths where surfaces should shine, gathers itself into a persistent argument for emptiness. Yet you may also sense the humility with which science holds these conclusions. The inference is strong, but not infallible. There are still uncertainties in the models, possible changes in the efficiency of radiation, geometries that might allow some energy to escape detection, and faint unknowns at the edges of theory. What is certain is that for any luminous border to survive the current suite of observations, it must either radiate with a near-zero efficiency unimaginable for known surfaces, or else play out its drama in some hidden, carefully tuned corner of the physical world. Let this realization sink beneath your skin for a moment. The lack of persistent infrared or millimeter emission from Sagittarius A, strand from analogous cosmic heartstands, to date, as perhaps the strongest indirect evidence for horizons, those mysterious boundaries beyond which no energy, not even hope, escapes. The silence is not accidental, not a temporary investigative gap, but rather the shared silence of the universe itself. It teaches you that a border, if present, must be shrouded so perfectly as to challenge not only our best instruments, but also our deepest convictions about how energy, surfaces, and the laws of thermodynamics are bound together. From this, you may glean a softened comfort. In science, as in every thoughtful life, the unspoken and the unwitnessed take on their own gravity. Effort is not always rewarded by revelation. Sometimes it brings instead an ever-sharpening constraint, a growing discipline of what can and cannot be. You are invited to cherish the uncertainty, to appreciate how negative results structured, disciplined silences steer us just as forcefully as the flashes of unexpected brightness. And, as your mind winds toward rest, perhaps you find yourself wondering what kind of world this makes for the imagination. If, at the heart of our galaxy, and so many others, the darkness is not merely a visual absence, but a physical silence. If this quiet is the signature of an event horizon so perfect that it surrenders not a single photon dose, this elevate the story of the black hole to the level of cosmic poetry? Or does it, instead, keep you company in your own uncertainties, reminding you that sometimes it is the things which do not burn, do not cry out, that carry the sharpest meaning? If these thoughts have set something alight within you, a gentle appreciation for the craftsmanship of negative evidence, for the integrity of not knowing, take a moment, if you wish, to share your feelings below. The absence of a surface glow from Sagittarius A star is, perhaps, as deep and enduring a mystery as any story astronomy can offer. In the great, quiet center of our galaxy, the silence is articulate, each non-photon a syllable in a poem of cosmic reserve. Perhaps, in your own struggles with uncertainty, or during those nights when resolution feels impossibly distant, you'll find kinship with this silence, and allow it to teach you how the universe, too, builds knowledge as much from restraint and absence as from brilliance and acclaim. As you drift, let yourself be soothed by the idea that in some corners of reality, silence is the truest voice. In the discipline of astronomy, in the discipline of your own living, patience with uncertainty may itself be a kind of answer, a radiant stillness, more eloquent than persistent noise, more enduring than any fleeting flare. And, in the hush between stars, both you and the universe are quietly, patiently, learning together. Let your thoughts linger a while longer on that profound silence inhabiting the center of our galaxy, a silence handed down by nature not as an accident, but as an intricate response to the most persistent human curiosity. This absence, this eloquent darkness, has been patiently forged over decades, not just by the limits of telescopes or the theories that shape them, but by the universe's own commitment to revealing its layers only to those who listen with reverence. The discipline of not knowing, the humility of abiding in constraint, has drawn you irresistibly to an intellectual edge where wonder and careful skepticism walk hand in hand. And it is at this thoughtful boundary that another question stirs. If the universe so deftly prefers these silent abyssal hearts, the black holes whose evidence for horizons is currently so convincing, what of the other possibilities? What of the rich taxonomy of theoretical objects, birthed both from mathematical fancy and the deepest attempts to reconcile gravity and quantum nature? From the quiet, shadowed center, allow yourself now to drift through the menagerie of cosmic alternatives, each one a testament to the audacity and humility of searching for what might yet be. Think, for example, of the boson star-an object, proposed as both trail and answer to questions our standard models cannot fully contain. Instead of being built from the usual atoms or even the compacted neutrons that compose the densest stars, a boson star arises from quantum fields more fundamental, a gentle congregation of hypothetical particles, such as axions or other dark matter candidates, bound by gravity, but unlike anything you see in the periodic table. In these stars, matter is not organized as individuals or nuclei, but as a coherent wave-like field, the closest thing to a cosmic puddle of quantum dew. Across decades, speculative work has described how these stars could achieve remarkable densities, even mimic some aspects of black holes, their compactness pushing nearly to the brink of shadow casting. Yet, when pressed to radiate, to reveal a thermal boundary, or to leave behind the smoking gun of a horizon, the boson star's surface is physically present, and thus, ultimately, it must shine, if only faintly, in ways a true black hole cannot. Let your mind wander further to wormholes, those tantalizing bridges that connect disparate corners of space-time, the wildest expression of Einstein's equations. Popular imagination loves the idea of a shortcut, a passage through which information, or perhaps even matter, might emerge elsewhere, untouched by the rules that bind light and time to their usual fates. Yet, For a wormhole to mimic a black hole and escape detection, numerous physical demands must be met. Stability against collapse, traversability without catastrophic tidal forces, and, of course, the suppression of energetic signatures that would betray its throat as anything other than a normal event horizon. Most models require forms of energy unknown to today's laboratory ESO called exotic matter to keep the throat open. And like any border that is not a perfect horizon, a wormhole too is predicted to radiate, to leave spectral clues, to confess its difference in echoes or thermal emission long before its geometry would. Across this bestiary of alternatives, you find the ecos, or exotic compact objects, a family that embraces the weird and the almost plausible. Each vibrating not in open vacuum, but tightly pressed against all the others, erasing both singularity and horizon by sheer combinatorial complexity. Or perhaps picture the regular horizonless objects imagined to solve the singularity problem by smoothing out the core, or Gravastars themselves, with their phase transition shells and stubborn near-horizon borders. All these alternatives share a common logic. They try, by hook or by fundamental novelty, to evade the ultimate abnegation imposed by a classical horizon. They offer new ways for matter and information to persist, to be encoded, or later released, when a black hole by design would simply erase. It is only natural that, when so much of your hope for meaning rests on distinguishing objects by experience, you wonder, how then do you test what is real and what is possible? This is where the conversation matures beyond mere possibilities into the strict discipline of physical evidence. Each of these object classes is tasked with passing the gauntlet of tests offered by modern observation, a journey as real as any life's, governed not by fantasy, but by hard-won cumulative constraint. You find, first and foremost, the question of the horizon. Is there genuine evidence for a surface where all light and information vanishes, or does even the faintest glow escape? This is the surface test, perhaps the hardest hurdle for boson stars, wormholes, gravastars, and fuzzballs alike. As you learned earlier, the absence of a strong, millimeter-bright surface glow in Sagittarius A star and comparable nuclei across the universe dramatically limits the sort of surfaces or shells these objects can possess. Without inventive and highly specific explanations, a surface that absorbs but does not re-emit heat is nearly impossible to square with established physics. Hand in hand with this comes the search for echoes, time, delayed signals in gravitational waves or electromagnetic outbursts that would arise from matter or energy meeting a physical surface, bouncing and returning a detectable signature. Black holes offer no such echo. The horizon is an absolute one-way gate. But for ecos, there is always the risk that some fraction of energy returns, leaving the faint, periodic stamp of difference. As of the current era, as you know, systematic and statistically rigorous searches have found no such pattern in gravitational wave datasets, a silence that squeezes the most generous parameter spaces for these alternatives ever tighter. Move forward in your reflection, now, toward the beautiful images sent back by the Event Horizon Telescope. The EHT has resolved the shadows of massive objects at the centers of galaxies with unprecedented acuity. Embedded in those images is the signature of light bent by gravity at a distance so precise that the geometry must echo the predictions for a Kerr black hole, the spinning, real-world analog to Schwarzschild's ancient ideal. Here again, at the level of present precision, black holes win. The observed shadows do not require, nor do they admit, large deviations that would be offered by most modeled alternatives. The edge is sharp, the size is correct, the lensing ring aligns fuzzballs, boson stars, and wormholes quickly find themselves needing ever more subtle and contrived configurations to avoid detection. But even this is not the complete story. There remains the logic of thermodynamics, the need for energy, when blocked or transformed by a non-horizon border, to go somewhere. In objects with physical shells or throats, the energy must be radiated or otherwise hidden from view. Constraints on the luminosity from accreting matter thus exclude large swathes of parameter space for such objects. As more light curves are taken, as more shadows measured, as more gravitational waves catalogued, the room for exceptions narrows. Yet, in the midst of this, you are reminded not to lose hope for fruitful ambiguity. Science thrives not by rapid closure, but by the patient narrowing of possibility, by the humility to recognize that answers grow only through evidence layered over time. Black holes remain the strongest, most parsimonious explanation for what is seen, a model that meets challenge after challenge with an unsettling elegance, but none of their competitors has yet been ruled out in absolute, final terms. In some small, contrived corner of theory space, a wormhole, or a boson star, or a gravastar of astonishingly low emissivity could still be lurking, passing every test by the grace of fine-tuned improbability. You are invited to savor this, the reverent discipline of science, which seeks not dogma, but the slow art of exclusion. With this frame of mind, allow yourself to find comfort in the company of uncertainty. You too must often balance the desire for definitive endings against the value in remaining unsettled. The universe, in its magnificence, offers a zoo of possibilities, and then gently, sometimes relentlessly, makes many of them unlikely, but does not erase the wonder that gave rise to them. In the quiet intervals between measurements, or in the long nights before a new observation is made, it is this persistent company of alternatives that feeds both imagination and discipline. If you wish, I invite you to leave your own sense of possibility, favorite candidate, for a hidden cosmic answer in the comments below. Which alternative best speaks to your intuition? Where do you sense the greatest beauty? In the stoic silence of a true horizon, or in the shrewd evasions of a universe still rich with secret borders and underground passages? Let your reflections be a thread in the larger tapestry, a way to stay open to novelty, even as evidence quietly constrains it. And so, whether you are gazing at the empty core of the Milky Way from your balcony or resting in thoughtful darkness, remember that the search for what lies beyond the black hole is, at heart, a quest to discern the grammar of existence itself, how corners of being are shaped, where boundaries truly lie, and what it would take for someone to finally astonish you enough to believe, if even for a breath, that the abyss might not be a silence after all. Let yourself drift for a moment into the permission you have been given, across these long explorations, to imagine alternatives to treat the darkness not only as a muster of evidence, but as an invitation to journey. You have followed the quiet logic of limits, observed the discipline with which each hypothesis is tested and narrowed, and faced the truth that some borders may never be fully crossed by knowledge nor by light. Now, accept the gift of the thought experiment, recognizing how science and contemplation, at their highest, both cherish the power of inner travel. Feel, if you wish, the sense of poised anticipation that comes in the seconds before you draw mentally close to something few have truly pictured. What might it actually be to approach a gravastar, to leave behind the safe abstraction of equations and step as close to the mysterious shell as any consciousness yours or another sever has? Close your eyes, if it helps, and suspend your disbelief long enough for a personal tour guided, not by fantasy, but by the disciplined, informed imagination that emerges from all you have patiently gathered about these cosmic mysteries. Begin, perhaps, with the approach itself, the journey from vast emptiness toward the center of a galaxy, the black silhouette that, from light years away, was known only as a shadow on the luminous fog of stars and dust. As you accelerate, drawn ever deeper by gravity's irresistible call, you sense the familiar paradox. From the outside, everything still appears uncannily like the domain of a black hole. There is the accretion disk, radiating in every band of the spectrum, and jets or hotspots or flickering flares, all conforming to the choreography that the universe has performed for centuries. Space is warped. Time, for you, seems to slow the closer you come, the more the clocks in your imagined spacecraft fall out of step with some far-off observer's time. At first, the experience colors itself with recognizability. The tidal forces tug at your craft, warning you that you draw close to a place where gravity compresses and stretches everything in dramatic fashion. The effect is strong, yes, but not quite infinite, because you are not yet at the border, merely at the steepening slope where the geometry of space-time pinches and folds light, and even the stars behind you become distorted and blurred. Here, the once simple rules of up and down, near and far, lose their usual clarity. A photon, launched backward over your shoulder, follows a strange arc, rounding the entire object before returning to you from ahead, a common fate for light near the photon ring. Imagine now that you decide to cross into the technical region where ordinary matter or radiation would become lost forever in a traditional black hole just beyond the so-called photon sphere, pressing toward the critical radius. The sense of suspense grows. In a black hole, the only story left would be the slow redshifting of your signals to oblivion as your spacecraft is swallowed, the ultimate privacy of fate. But here, in your Gravastar journey, the story is poised to twist. You remain propelled inward, perhaps still surrounded by fragments of accreting plasma or the cold fire of billion-year-old cosmic rays, until finally you confront the shell. This is not a mathematical nothingness, but a surface thin, almost unfathomably rigid and dense, yet present. Picture for a moment the contact. If you send a burst of light from your ship, rather than being lost, it finds the border, some photons absorbed, others perhaps scattered or re-emitted. If you throw a sensor, a probe, even a fragment of matter, it is not doomed to infinite descent, but meets resistance. What the shell feels like, what sound or vibration or signal it gives, depends intimately on its composition, which is still a matter of deep speculation. But this is a place where nature has chosen not total silence, but a final, ambiguous reply. From your own perspective, time would move normally, but for that distant astronomer on the outside, your every motion slows and dims, redshifted into practical invisibility. This is a taste of relativity, the two views both anchored in the truth of physics, both holding different slices of an event none can fully share. But from the inside, looking outer rather from just at the Shelliator, is a private one. You observe, perhaps, the temperature of the Scheller perfect absorber, nearly black, or perhaps faintly glowing depending on models, but in any case, utterly contrasted with the expectation of absolute darkness and fate. If you choose to shine your flashlight straight into the shell, some of that light, in certain theoretical frameworks, may bounce back, not in a continuous, exuberant response, but rather in a soft, time-lagged echo-delayed whisper that tells you unequivocally, here is a border. Imagine the faintest glimmer, reaching your detectors a fraction of a millisecond after you shout with your photons. You could record that echo, study its spectrum, perhaps see the imprint of the shell's exotic matter or quantum fields in the way the light is shifted and changed. Pause for a moment to imagine a more dramatic turn. Suppose you are not alone in this endeavor, but part of a fleet of small probes, each with clocks and cameras, automata sent to map and return from the edge. As they touch down at various points on the shell, they record its tension, the resistance it gives, the minute vibrations as plasma from the accretion disk crashes into the surface. Some sensors register nothing but silence, others pick up a faint, trembling signature, a direct analog to a bell's aftertone after being softly struck. Each return pulse, perhaps carrying the tiniest fraction of information from the collision, would be catalogued, stacked, perhaps even used to deduce what lies beneath whether that erstwhile interior is shockingly calm, as in a vacuum inflationary state, or trembling with quantum storms beyond the reach of most physical theories. Step back now, and allow the sequence to play out in longer time. The shell, too, is not immune to the marathon of cosmic time. If over eons it is battered by torrents of infalling matter-star dust, wayward comets, even unlucky starset responds by absorbing, resonating, perhaps gradually altering its surface, or its spectrum of emitted energy. Radiation seeps away not in the relentless, pent-up collapse of black hole entropy or the feverish burst of an exploded star, but as a measured, sometimes delayed pulse, acting out the balancing act between pressure from inside and tension from without. If your mind finds this almost comforting, as if the cosmos too appreciates the idea of a surface where returns are still possible, then you have discovered a kind of kinship not just with theory, but with the universe's own reserve. Here, borders are not simply final, they speak back, sometimes in their own language of echoes, delayed flashes, or spectral changes. In such an environment, the deepest existential question, what happens at the edge of knowledge, finds a partial answer. Sometimes, at the last boundary, there is a wall thin enough to be crossed by hope, if not by certainty. Continue to explore the scenery in your mind's eye. The accretion disk, just outside the shell, boils and swirls, its plasma occasionally whipped into arcs and hotspots by magnetic fields and the sheer violence of gravity. These hotspots, moving at tremendous speeds, sometimes approach the shell so closely that their light, lensed by the Gravastars' mass, creates almost perfect rings, just as seen in black hole shadows. But if you could watch from centimeters above the shell, you might catch the rare photon that interacts directly with the border, instead of being swept away. The energy budget, the angles, the fleeting time it takes for emission or absorptional become messengers whispering that, here, physics has made a different choice. There are moments, too, when cosmic rays or stray atoms spiral so close as to be swallowed not by a mathematical abyss, but by this hard, unyielding surface. Perhaps most are absorbed without a trace. Maybe, in the briefest intervals, a few are re-emitted, their direction and energy slightly altered. Over billions of years, some patterns emerge across the statistic subtle shifts in composition, faint anisotropies in outgoing radiation that, for the patient, could provide a census of the shell's response, its interaction with the universe's ceaseless reign. Imagine, finally, the pure stillness of standing just above the Gravastars' border, adrift in your vessel, meters or centimeters from the ultimate edge. Look down, below. All is impenetrable, unseeable, but also not truly void, not an eternal swallowing. Look up. Compute the way light and time behave, stretching, circling, returning, as the universe's ordinary laws still hold sway, however stretched. Listen to the quiet, broken only by an occasional echo or tremor, and recognize the profound difference between the silence of utter consumption and the possibility of delayed return, of reflective resistance. You might sense, as you savor the conclusion of this mental tour, that such an encounter has left you with a new appreciation of borders not just in physics, but in your own living. The Gravastar is both alien and surprisingly familiar, a paradox, the most extraordinary riddle dressed in almost perfect commonality. Up close, that difference becomes transformative. Sometimes, the boundary is not a curtain, but a drum. Sometimes, what seems endless darkness harbors a silent, watchful frontier. Let this narrative sit gently with you as you begin to close your eyes for the evening. In the quiet, recall how often the boundaries in your own life, those between what you know and what you cannot reach, have felt, at once, insurmountable and inviting. Perhaps you too have wished for a shell rather than a void, for a place that answers softly, even if incompletely. And if this story has inspired a moment of wonder or a question blooming in your thoughts, I invite you to share it with others below, for every reflection, like an echo from a cosmic border, finds its meaning in returning. Tonight, then, let yourself rest with the knowledge that, even at the edge, the universe may offer not negation, but conversation. What waits beyond the Gravastars' shell remains a riddle for future minds and future instruments. But for now, imagination and inquiry together allow you to circle its border, listen for the quietest reply, and find meaning and perhaps solaceate the astonishing, indefinable boundary between all the universe contains and all that still awaits. Breathe deeply, and let the contemplative image of that immense, silent frontier, the Gravastars' border, shimmering with possibility, linger in the corners of your imagination. You have just traveled up to the edge of the unknowable, allowed yourself to feel the surreal intimacy of floating near a shell that is real but untouchable, a surface that might give back an echo rather than only a final, infinite silence. As your thoughts settle around this astonishing picture, there arises a new, sobering curiosity, one that does not merely rest on the solitary encounter, but asks how the universe itself would subtly transform if gravastars, these improbable alternatives, were not mere singular exceptions but commonplace, scattered through space, masquerading in numbers as black holes do. How would your cosmic map be reshaped? What hidden signatures would ripple across the eons if a significant share of those storied black holes were, in fact, gravastars all along? Permit yourself to let the implications expand gently, as though you are standing on a high mountain, looking down over valleys of unknownsome shrouded in mist, others flickering with the first rays of understanding. At first, the change would seem minimal. After all, you now know just how artfully the gravastar conceals its true nature, its gravitational pull, its warping of space and time, its silhouette etched against luminous matter, even its magnetic and electromagnetic whispersaw of these mimic with uncanny perfection the profile of the black holes enshrined in our catalogues. From the perspective of a distant observatory or a model of galactic evolution, the old expectations would at first glance still appear to hold. But pause and allow your mind to probe just a little deeper, to follow the branching chain of consequence, and consider how, over vast stretches of both space and time, the universe would be tilted in subtle and accumulative ways. Turn first to the theme of galactic history and the budgets of mass and energy. Black holes, as you have grown accustomed to imagine, are objects that devour matter with finality, converting some fraction of it into radiation through accretion outbursts, jets, flare sand swallowing the rest into oblivion. Gravastars, with their physical shell instead of a horizon, would rewrite parts of that script. Matter falling onto a gravastar, meeting resistance at the shell rather than disappearing past a mathematical horizon, experiences a final interaction. Depending on the shell's exact properties, a fraction of this energy might be recycled, released once more as delayed light or heat, or perhaps in some conditions only minimally so. Regardless, the energy accounting is not quite the same as for a true black hole. Over millions or billions of years of steady accretion, these subtle differences in efficiency not so much in the fireworks of bright jets but in the dull, cumulative total of all matter that passes into these objects would, in aggregate, alter the thermal and radiative stories of entire galaxies. The centers of galaxies, the cores of massive clusters, the balance of hot and cold gas drifting inexorably inward all might tip ever so gently, a butterfly's wing beneath the cosmic weather, leading to histories that diverge from current projections. If you allow yourself to trace this thread far enough, you can imagine astrophysicists in some distant future, puzzled not by the lack of individual events, but by the subtle patterns. Why are the most massive galaxies just a little dimmer or a little brighter in the middle than models predict? Why do jets sometimes fire with energies that do not match the neat expectations of event horizons swallowing mass in silence? The answer, perhaps, would be woven through decades of only just perceptible anomaly, a universe that never quite matches the mean forecast, each deviation a quiet vote for surfaces not horizons in places. Most had assumed only endless void. Let your reflection walk now into the noisy ballroom where compact objects pair and merge, giving rise to the gravitational symphonies recorded on our world by LIGO Virgo, soon by Lysa and detectors yet unborn. Black holes, when they dance and collide, produce post-merger ringdowns of exquisite precision, the clean, exponentially damping music of a new event horizon settling into its stable shape. Gravastars, with their shell just outside the Schwarzschild radius, offer a new coda. The possibility of faint echoes, delayed ripples bouncing between the shell and photon sphere, modifying the purity of the ringdown with subtle aftertones that would, with enough events piled high, form a chorus of different. If gravastars populated even a modest fraction of the compact object population, a careful audit by the next generation of gravitational wave scientists might begin to unearth these repeated signatures not as isolated novelties, but as a statistical excession implication not of an accidental oddity, but a cosmic plurality. And what of the budgets of cosmic information? Here, the meditative pause grows heavier. Black holes have always been metaphysical as well as physical objects, their event horizons serving not only as gates for matter, but as the ultimate erasers of information, giving rise to paradoxes that prick at the deepest assumptions of quantum mechanics. Gravastars, by interrupting collapse at the threshold, offer a new hope, a surface that, no matter how extreme, remains part of the observable universe, in principle capable of storing and, perhaps, over unfathomable time, scales releasing the information about all that falls within. If a universe were seeded with gravastars, the script for information's fate would be dramatically rewritten. Evaporation, unitarity, the esoteric play of quantum hair and entropy would be entirely altered, the universe's record-keeping fundamentally more thorough, less prone to despairing erasure. Let yourself remember, too, the nature of cosmic checks and balances. If gravastars exist only in pockets among certain mass ranges, or in environments shaped by unusual histories of star formation or metallicity, then their statistical fingerprints would be subtle, isolated mostly to rare environments. But if, in the grandest stroke, gravastars exist wherever black holes are expected, and in approximately equal number, then the universe would wear extraordinary disguises. Galaxy building would demand new parameters: how energy escapes, how active galactic nuclei shine, how growth proceeds or stalls in different corners of the cosmos. Imagine now the shiver of anticipation among theoretical physicists and astronomers everywhere as they digest these possibilities. Faint errors in jet power, tiny mismatches in the heating of galactic gas, missing or extra echoes in the ring-down catalogues, the preservation or loss of cosmic information. Each of these might be the indirect voice, arguing that some part of what you once called black hole could be an imposter, a gravastar rounding out the census. Before you leap to claim this as a revolution, allow the second, quieter lesson to settle in. For every hypothesis, there is the relentless discipline of data. The landscape of possibility, even for something as phenomenologically adaptive as the gravastar, must be continuously winnowed by what is seen. The past decades of electromagnetic observation, the relentless searches for surfaces both thermal and faint, the absence of expected radiative signatures, the lack of systematic echoes in the ring-down soul, these have already pressed the possibility of widespread gravastars into a narrow corridor. For a significant population to exist, their shells must possess properties ever more finely tuned, radiating less, reflecting perfectly, resisting all the mechanisms that would otherwise unmask their identity. The more you ask for gravastars to be common, the more you must pay in the coin of improbable, almost conspiratorial alignment with the silence of all available data. What then does this balance mean, not only for science, but for your personal philosophy? Perhaps it is here that the contemplative spirit of this entire journey becomes most powerful. You are allowed, indeed encouraged, to hold paradox, to accept, with open eyes and a quiet heart, that the universe may still harbor secrets, but that each secret abides beneath a growing weight of discipline. As the evidence accumulates, as your tools sharpen, the space for novelty grows smaller, but not yet vanished. This is the lesson both of patience and of joyful skepticism, sense that every narrowing of possibility is not a defeat, but an arrival at a higher plateau of knowing, one approached with humility and grace. Take now the gentle liberty to let this thought refract through other aspects of your living. How often do you carry, in your own routines and regrets, the hope that some unexamined part of a story, some hidden parameter, will prove the real explanation for a pattern you cannot otherwise resolve? How often do you, like the astronomer tracing the light curve of a distant core, find yourself hoping for the echo, the anomaly, the proof that the most radical answer has been present all along? And in what ways, as the data of your own days becomes more refined and abundant, do you find it both bracing and humbling to see those possibilities narrowed, to know that some things must be rare or precious, or perhaps only ever possible in imagination? Perhaps this meditation leads you to a new kind of calm. The search for gravastars as secret constituents of the cosmos is not merely a competition to win over black holes, or to prove oneself more clever than the rest. It is the practice of paying attention with profound sincerity. For each possibility not realized, there is a newfound clarity in what remains. For every echo not heard, a redoubled admiration for the beauty of silence. Science proceeds not as a fast march to certainty, but as a slow dance with mystery, one whose rhythm is set by the universe, and whose steps are measured in patience. And so, as the night deepens around you, let your mind return, finally, to the meaning of a cosmos in which some share of these mighty holes in space are, in fact, gravastars, the sum of all the echoes, all the slightly brighter or dimmer galactic hearts, all the unspent information lighting up the future with new hope or ambiguity. Let this be not only a question in astrophysics, but a call to mindfulness in your own story. What, after all, would your life's map look like if borders proved permeable, if secrets once thought vanishing could echo back, or if some of what you call loss was only delay information waiting patiently within a shell, bound to return when you learn to listen with enough ingenuity and tenderness? If that resonates with you, I invite you, as ever, to share your reflection below to find kinship with others who walk this careful path, honoring the twin demands of skepticism and imagination. For here, at the nearly invisible threshold where event horizon and physical border converge, where science is both a pursuit and an act of reverence, you find the richest possible meaning, that the cosmos, like the mind that contemplates it, grows ever more extraordinary the longer you are willing to linger, to wait, and to wonder at what might still yet be revealed. Let yourself rest for a moment within the serenity cultivated by contemplating a universe that continues to keep part of itself in reserve and ever, quite yielding every secret, yet always shifting the boundary lines of what can be known. As you find yourself reflecting on that delicate dance between bright possibility and relentless skepticism, you sense the need for a gentle reassessment. Where, truly, do we stand, now that so many echoes have faded without confirmation, and so many imagined luminous borders have remained dim, and yet our curiosity endures, vibrant and unexhausted? Allow your attention, then, to inhabit fully this present moment in science's journey, a moment rich with the cumulative experience of patient years, yet also pierced by the first questioning beams of what comes next. As of this year 2025, the landscape of Gravastar research has been sculpted with care and discipline, marked by a slow, almost meditative winnowing of the conceivable. If you trace this contour with your mind, you find that every year another layer of uncertainty is gently peeled away, not by dramatic pronouncements, but by an increasingly precise accumulation of data. You sense the weight of experience in the regular, unfailingly calm images returned from the Event Horizon Telescope, that planetary-scale marvel of astronomy which, over multiple observing campaigns, has confirmed the unchanging, shadowed silhouettes of both Messier 87's supermassive heart and Sagittarius A star. These shadows, cut almost perfectly to the measurements expected of a Kerr black hole, suggest with every update that if gravastars with luminous shells do exist, they are, at most, masterfully hidden, possibly only permitted, if they radiate with a chill so perfect as to resemble true void. Yet, acknowledging this, you notice how the search sharpens ever further, how astronomers have begun to call for longer and longer stretches of time-resolved imaging, asking not only, is there a shadow, but does anything over the weeks and months subtly shift at the edge? Does any hotspots arc or flare? Does any flicker in the pattern of brightness whisper an unambiguous new tale? The seriousness of this approach is itself a quiet marvel, a demonstration that even when no deviation becomes the loudest headline, the art of patient inquiry is practiced at its highest level. Meanwhile, in the gentle hum of radio dishes and the careful watches of millimeter arrays, the absence of robust surface emission from Sagittarius A star and other core objects has pressed the luminous border alternatives into the narrowest of corners. Every further deep measurement in the millimeter and infrared strengthens the argument that, for the most part, what lurks at the centers of bright galaxies are voracious beings, whose energy budgets are explained by accretion alone, not by re-radiation from matter crashed into a waiting shell. Allow that to become a part of your resting wisdom, a kind of melody that repeats softly in the background, a counter-melody, perhaps, to the drama of discovery. You recognize how, in other quarters of astronomy, the orchestra is changing instruments. The communities working with gravitational wave detectors, first with LIGO and Virgo on Earth, now with immense anticipation for the emergence of even more sensitive detectors, and with growing expectation for the dawn of LISA's watchful vigilance in the quiet of Spacehave, brought forth catalogues bristling with mergers and ringdowns. Each event is probed, stacked, analyzed for even the faintest sign of an echo, the time-lagged return from a reflective shell, the telltale memory of a border so close to the brink, it might still betray its presence. With the discipline that becomes second nature to those searching for meaning amid noise, the absence of echo signatures, at least to the present threshold of statistical certainty, asks that scientists be as skeptical with hope as with fear. Yet if you lean closer into the story, you sense that the invitation remains open. The silence is not final, but provisional, held only until the next doubling of sensitivity or the patient accretion of further years' worth of data allows fresh kinds of patterns to be sought. The promise of future ring-down searches at ever greater statistical confidence lingers like a soft dawn at the edge of night. In parallel, the next era of the Event Horizon Telescope's program beckons. The ambition grows not only for more images, but for movies, for sequences of observations in which the dance of hotspots, the trembling of plasma arcs, and the muted choreography of orbital fire show themselves in time, not just in stillness. These moving images, layered with the richness of multi-frequency data and new interferometric insight, will allow hunting for variability of unprecedented nuance. If a border is there, if the universe has hidden a shell within the shadows we see today, it may yet confess itself through the tiniest, repeated oddities in phase or brightness, or the microstructure of delay and rebound inside the glare of a flare. That prospect is itself a lesson in contemporary scientific humility. Even the best hypotheses, even the most beautiful pictures, find themselves kneeling before the slow, unglamorous march of cumulative evidence. Each time a new featureless ring is mapped, each absence of echoed ringdown is catalogued, or each failed hunt for surface heat is logged, the possibility space contracts. Yet it contracts with grace, never with violence. You understand now that the progress of science is not a gauntlet for heroes, but a patient keeping of accounts, an ongoing, living dialogue between what might be and what will eventually remain. Imagine yourself for a moment attending to the larger horizon, seeing, as do the architects of the next generation of telescopes, how each constraint is not an end, but a prelude to the new, higher precision questions that now become possible. The history of 2 decades has seen the transformation from mere dreams of black hole silhouettes to the certainty of shadow. Now, the promise is for movies, for millimeter-bright spots tracked frame by frame, for far more refined checks on the ring-like edge where hotspot emission might whisper a difference. Side by side with this, the promise of longer wavelength, wider baselines, of global networks in partnership, all point to a future where the once subtle may become the resolvable. You awaken, in these reflections, to a sense of communal progress, that each result, even a negative one, is not only an individual station, but a lantern passed forward. The younger generation of physicists, newly trained in the world of machine learning and advanced algorithms, find themselves less discouraged by silence and more attuned to mining silence for structure, to plumbing absence for the clues that remnants of a different future may still hide. This discipline, a kind of spiritual patience layered atop technical mastery, defines what it is to do meaningful work in the cosmos today. Drift, for a while, into this sense of time, not as a rush toward a destination, but as a gentle accumulationer gathering, season by season, of better ways to ask. You realize perhaps how every community flourishes not in discovering all at once, but in returning to the same puzzles with ever more refined tools. How reconstructed time series can catch echoes, where once there was only static. How better calibration of detectors can squeeze out errors masquerading as events. how 100 new mergers may allow, for the first time, a decisive test of even the most fleeting aftertone in Gravastar-inspired scenarios. Catch, for a moment, the tinge of humility that pervades the work of the most seasoned observers. The provisional verdict, 2 decades into this gentle narrowing of the extraordinary, is that the Kerr black hole bereft of border, silent behind its mathematical mouth, remains the standard that best accommodates all we see. The Gravastar, for all its theoretical elegance and conceptual ambition, has not yet been crowned by the evidence. Instead, it occupies a slender space on the philosophical margina reminder of how the universe never fully exhausts its catalogue of the possible, how even the quietest dreams leave a certain residue, impossible to erase. And yet you also know, in the quiet of your own honest thought, that the story cannot altogether close. You sense how each epoch has, in turn, marked its best theory with the gold of certainty, only for future minds, with new tools and deeper patience, to find a residue unexplained, a data point that does not fit, a pattern that beckons further attention. It is not just a matter of humility, it is a living principle, the way the universe trains those who would learn from her, not only to answer, but to listen. Let yourself embrace that wisdom. Every open hypothesis deserving of care is one you must follow not until it shouts, but until even its softest implications are gently, surely known. So, as you sink further into the end of this meditation, ask what it would truly mean for you to rest within this state of science's journey, a place where the most plausible answer remains standing, but where the most alluring question continues to shine from beyond the horizon of knowledge. How might you, in your daily experience, practice that rare combination, a rigorous hope, a skepticism not of closing, but of tending a fire until the fuel is truly spent? At home and at rest, in the balcony's dim glow or the hush of your own room, you can learn this lesson anew, not only about gravastars or black holes, but about the meaning of patient knowing in all areas of your life. If the universe, after so many careful tests, still leaves room for a shell where you expected a void, for an echo where you expected silence, let this teach you to leave some door open on your own uncertainties, not as a mark of failure, but as an offering to what might yet return. Let the shadows become invitations. Let the absences speak as clearly as the presences. If you feel moved to do so, I invite you to write of your wonder, your doubts, or the ways in which science's posture of listening rather than declaring resonates with how you too have learned to wait, to hope, and to notice. Tonight, as you draw your contemplative journey to a close, rest in the simple, gentle promise that data and patience still rule the slow power that, in the world of flesh or the deeps of space, turns every no into the ground for the next when or what if. The gravastar, the shell, the horizon, the echo or its absence, each is not so much a conclusive answer as a continuous musica thing that bears you onward, deeper and deeper, toward a universe always more generous than even the most learned mind could plan. And so you carry with you, like a cloak or a lantern, not only the knowledge of what is, but the hope of what still may be.